here today to talk about software bill of materials, software vulnerabilities, and software composition analysis in the greater context of a software supply chain. It's a very, very big topic, so we'll cover all the bases, but in variable depth according to the subject areas. I hope this is useful, and let's get started. So generally what we're talking about here today is two main concepts: software bill of materials and software composition analysis. These are very common terminologies in the industry without clear definitions. So having a good idea of what they mean and how you will apply them is very important to manage the growing risk of software vulnerabilities and other compliance issues, licensing and others. So we'll talk about SBOMs, software composition analysis, what it is, how it relates to SBOMs, and we'll end with an overview of nexB's solution in this area to help you manage software supply chain risk. So these are the topics. Our primary focus is free and open source software. We call that FOSS. Other people call it OSS. But it's very important to know that most of what we're talking about also applies to all kinds of proprietary or closed source software. And most modern proprietary software contains free and open source software, often up to about 80%. There's many different ways to count this. So that's always an approximate number, but that's a common assertion from studies and so on in the industry. So basically the FOSS is everywhere. Open source software is everywhere. So starting off, we'll talk about a software supply chain. Supply chain is very, very topical with COVID and other global events. But it's an old concept. And in our discussion today, we're mostly going to be talking about concepts that were borrowed from something called discrete manufacturing. Discrete manufacturing is when you manufacture something out of concrete things or discrete things. So it could be a television, it could be a toaster, could be a computer, as opposed to process manufacturing, which is where you would handle things like food and pharmaceuticals. Software bombs have jumped onto the scene, starting with the May 2021 executive order from President Biden about the concepts, requirements for doing business with the government in the area of cybersecurity. And that focused on the broader concept of software supply chain. But we can see the concept of bills of material for software appearing back in 2014 in a bit of draft legislation that I don't think ever made it to the floor, but a full 7 years ago, people were already talking about this, particularly in the concept, in the context of vulnerabilities. So what is a software bill of materials? Well, it's basically a list of software components. Sounds kind of simple. Used in a product. A product could be anything. It could be a consumer product, could be a business product, could be something that's exchanged between two companies' supply chain. It's usually, the old-fashioned term is hierarchy. I guess people these days talk about graphs, but that's usually the nature of the list. Tricky part is nobody agrees on what is a software component. So the simplest way to think about it is a component is a file or a set of files, often called a package, but again, no standardized terminology there. If it's a package, so something you could think of as software you could download, it's really important to understand whether that's a package that contains metadata. In other words, there's information about its contents, sort of like when you get a package from Amazon and it has an Amazon label, or it's just a package in a plain brown wrapper, in which case you can figure out what's in it from looking inside, but until you open the package, you have no idea what's in there. The use cases are many, many different use cases. The most common one is packaged software. The old days, that was sent on a tape or a CD or DVD. That's typically downloaded these days. There could be another media. Software that's deployed or embedded into a device, like all the software that runs on a smartphone or a home gateway or a television these days. Software that's deployed on the cloud. So you use that software through some kind of service, but there's often very, very complex and deep software to support any sort of a service that you access, whether it's a website or something transactional. And it's important to know that it's a customer-supplier relationship. There are customers or recipients of an SBOM anywhere in the supply chain. So most of these software supply chains, similar to hardware supply chains, have many different steps. And at each point in that process, it may be relevant to share an SBOM with whoever is your customer in that supply chain. So what that really means is that anyone who distributes software in any way will likely need to produce an SBOM at some time. Many people are on the front line of that if you're doing business with the federal government. Others are much more in the background, but eventually everyone will need to both produce and likely consume an SBOM. So the main driver right now is that the US government is proposing very specific regulations that require you to produce an SBOM, attest to its accuracy and the level of information in it as a requirement doing business with a US government agency, which is obviously a huge market. So that, is the driving force that has brought SBOM to the forefront, but this has been an issue for a long time because for lots of reasons, but one is that most modern software contains third-party software, free and open source or proprietary, which has potential risks for licensing or vulnerabilities. And those are not new. They're not new at all, but the requirements from the US federal government and also emerging requirements from the EU are going to require people to be much more organized and rigorous in how they look at this. And if you have third-party software, something you didn't create yourself, you need some way to get information about that software so that you're not just passing on a vulnerability or other type of risk. So from our perspective, it might be a better question to ask, why haven't we been using SBOMs? In the manufacturing space, you wouldn't really be able to build a product unless you had a bill of materials and the information in it. Software, for a number of reasons, hasn't had that constraint, but where we're headed is that BOMs should be as integrated into the software supply chain as they are in the manufacturing supply chain. So one good way to think about it is that SBOM is not the actual management of license and vulnerability risks, it's the prerequisite. So essentially you have to agree on the identification of the software. So if you have an SBOM and it lists, we'll use the word components, even though it's not well defined, set of components, you have to be sure that you know what those components are. And there are no absolute standards for that. So that means you have to have some way of agreeing. Then I say I use this software component that you can recognize what that is. With the volume of software packages, particularly FOSS packages, this will have to be automated. There's no way to do this by hand and keep up. So it's basically, you should think of the SBOM as an entry point for managing the risks because it helps you identify what I'm calling a software unit. So a unit, people use words like package, component, and so on. Just some unit of software across the supply chain. The first thing is agreeing on its identity before you can start thinking about other attributes like the license or possible vulnerabilities or possible quality issues or other issues that you want to discuss with your supplier and share with your customers. At the moment, we're recording this in March 2023. There are two primary standards emerging for SBOMs. One's called Cyclone DX from OWASP, which is a security-oriented nonprofit, and another one called SPDX, Software Package Data Exchange, from the Linux Foundation. These are the two real contenders. There is another candidate called SWID, S-W-I-D, which does actually have ISO certification and so on, but it's essentially a private standard used by a number of proprietary vendors for previous work with the government. It's unlikely to become a general standard because it's not well suited for use cases outside that narrow domain. But it's real important to understand that the odds are there will not be one single standard. and it's possible there'll be more than 2. There may be new things that come up, in this area we don't know about today, and there are also ancillary standards, which I'm not going into today, but in any depth. But there are ancillary standards for vulnerabilities called VEXs and VDRs, and quite a bit and to absorb. So it's an area where there's a lot of dynamic innovation going on, and one of our messages to our customers is, you can't sit on the sidelines and wait for there to be only one, and this is something that's absolutely locked down and will never change. You have to start engaging with the standards as they emerge. Another key point about an SBOM is these emerging standards are designed for the exchange of information between organizations. They're typically using formats like JSON or RDF or something like that. They're not really something that you internalize as the design of SBOM data inside your system. Lots of reasons for that, but again, these are standards for supplier A to work with customer B so that they can understand the software and first off agree that they're talking about the same software and the same components, assemblies, parts, whatever you want to say, underneath that SBOM. SBOMs, I've mentioned several times now, they've been identified as a top priority for improving software supply chain security. They are not the only topic. There's many, many other topics related to the security of development environments, related to signatures on packages and so on. But this is what we're talking about today, is the SBOM side. At the moment, the Cybersecurity and Infrastructure Security Agencies, which is kind of leading the charge for the government, has 5 weekly meetings every week. Not sure that that's a good use of your time, but it tells you how many people are interested and how much discussion is going on. Another key standard that we'll talk about today, sort of underneath the SBOM, is how do you identify a piece of software, a unit of software. nexB invented, I guess you would say, or innovated a new specification called package URL that identifies most units of software. And this is now being adopted by all the other standards organizations, not necessarily as an exclusive identifier, but as one of the key ones. So again, it's just not a viable option to wait till all this settles down. You need to be participating in the process. The demand for most software organizations to provide an SBOM and associated information is going to be here quicker than any standardization on a single approach. And frankly, this isn't that much different from software in general, right? We're used to the fact the languages are changing, the platforms are changing. So it really doesn't make sense that standards for something that is so ultimately internal for software, would be static when everything else is dynamic. So a big picture item for talking about software supply chain is learning about what manufacturing organizations have done for a very long time. And essentially it boils down to, an organization or company in supply chain is responsible for knowing the origin, quality of materials in their product at their stage of production and sharing that information with anyone who's downstream. So in manufacturing, that meant you would agree on formats, one or more, for bills of materials. You agree on what units are. There are just dozens and dozens of different mechanisms for defining what are called part numbers or item numbers, usually in manufacturing. There's no way that those are standardized to a single list. You end up dealing with translation capabilities. So you can translate this part number here equals that part number there. It's not, again, a single standard. It's a set of standards. And you just have to learn to translate among the multiple standards that are relevant to your part of the business. Not everybody has to learn all of them. But these were just the very basic practices. If you were in a discrete manufacturing supply chain where you might, if you were building a computer, you get a power supply already built from some other company, but you design your own, motherboard. And then you buy memory chips from somebody else. And you have to know about each piece of this, where it's coming from, because you ultimately have responsibility for what you pass on to the next participant in the supply chain if there's some problem with the product. Your customer is going to come to you for an answer. So it's best you know that before you sell your product or distribute your product than after the fact. So what does that mean for software composition analysis? Well, it's, again, a big topic, but software composition analysis is another term that doesn't have a precise meaning. It was originally referenced most frequently by industry analysts like Gartner and Forrester. But what we've seen from the broad pictures, there's four main topics. Identification of the software unit. Again, I use unit because components and packages are not precise. So it's some unit of third-party software and also your own software. There's the licensing consideration. This could be open source or proprietary. Some argue open source licenses are more complicated. We would probably argue proprietary licenses are more complicated. In open source licenses, you have to understand the licensing terms and how your software is composed. In proprietary software licensing, you also have to understand all sorts of things like how many CPUs it runs on, or how many users you have, and so on. So none of it's easy. Security in this context, again, is focusing on security vulnerabilities for a software unit. So some piece of software that you're passing through the supply chain. This is, again, only a subset of all the security issues. There's dynamic testing for security, identification of malware, all sorts of things like that. But this is the fundamental part that we're covering in software composition analysis: known security vulnerabilities. And the fourth dimension is pretty broad, sometimes called health. We generally call quality, and that's evaluating the quality of a software unit based on various elements of software development data, which is generally available for free and open source software, not so much for proprietary software. And simplest way to think about it is number of bugs, number of fixes. In the open source world, you also look at the activity levels and the people and companies supporting a project and so on. So these are four dimensions that you have to cover at some level in the composition analysis. A little more detailed list, not going to go into each of these, but underneath the identification of the software components used, there's a very significant set of work about dependencies, which vary widely according to the platform you use, the frameworks you use, the languages you use, and they're all done differently in those different environments. So that's a huge topic of its own. Also, this distinction that I mentioned earlier between code quality, which is related to the number of defects, the number of problems reported in a product. It's important to remember that a vulnerability itself is essentially a defect. A vulnerability is a special type of defect or bug in code. Ultimately, it's part of quality. Versus community health, and community health has to do with if it's an open source project, evaluating who are the maintainers, how are they supported, how likely are they to continue, what's their track record, and including things like how quickly do they fix bugs, how quickly do they fix vulnerabilities. And it's sort of a broad topic of software composition analysis management. You've got all these different areas, so you need to have some way to pull them together. Some of these are pretty vertical and have pretty esoteric to some people, esoteric requirements. You need to get the overall picture of how you're handling this. So we're getting to a point where this type of analysis needs to be a core competency for any organization. There are, of course, individual projects where people are developing software themselves, all by themselves, single solo developer, but it's so rare. And even then, sometimes those people are building packages that are used downstream and can cause problems there. So you really need to build it into your software development workflow. We're not going to explain specifically how to do that today, but it really needs to start at the design level when you choose components, needs to go through every step of your development process, and clearly it has to be completed at the time you release the software. So it's not a core competency for a lot of organizations today, but it's going to need to become one. And the choice of your tools will depend on your platform, meaning your operating system, and are you cloud, or are you on a phone, or where does your software run? Particular technology stack you've selected, and the product itself. What does the product do? Who are the customers? What's the footprint of the software in the product? Is it the whole product as a software product? Is it part of the product combined with hardware, or something else? Software is just about everywhere. It does, of course, include things like IoT, the Internet of Things, where the software bill of materials may be fairly small for one of those, but because of the wide distribution of those devices, it's as critical as anywhere else. So what is the SCA Tools landscape look like? Well, these tools, various tools have been around for a long time, at least a decade, various ways. The primary focus has been on security vulnerabilities. So this predates the cybersecurity initiatives from the US government and the European Union. It's just, generally speaking, security vulnerabilities have a higher profile. Most people don't understand a lot about the details, but they can understand what the impact might be relative to all the news reports and so on. So that's typically been the bulk of the tools. There's a bit of a there's a bit of a dichotomy within the SCA tools between vulnerabilities and licensing. And to some extent, it's a little bit like oil and vinegar, because you have very separate interest groups or communities of interest. Security practitioner, cybersecurity is its own domain. It's quite technical, a lot of math, a lot of sort of science, STEM sort of flavor to it, and licensing as a legal flavor. So there are, of course, some people out there who cover both of these bases, but very different professions behind it, very different, again, communities. And one of the key things to understand is that license data can be very complex. We have been doing that for 12 years and seen everything. But the good news about license data is once you figure out what the licensing dimensions are for a particular product or a particular piece of software you want to use, it's usually going to be pretty stable. People are not changing their licenses very frequently. And they certainly can. You certainly need to be aware of it. It certainly needs to be part of your due diligence process when you're selecting software to use. But once a project is reasonably mature, it's unlikely to change the license in a significant way. And if they were to change the license in a significant way, it's probably going to be commented on be fairly prominent. The vulnerability data is also very complex. So you aren't dealing with legal concepts. You're dealing with questions of, okay, this vulnerability exists in this software, but does that really affect the way I use the software, which is a very complex question. But the second factor is it's extremely dynamic. So if you get an SBOM and it has vulnerability data in it, and you get that BOM today, it's pretty likely that data is out of date by next week, depending on the nature of the software you use. It may be that a vulnerability that was reported to you has been fixed, so it still exists in your software, but there's a fix for it. It may be that something that did not have a vulnerability when you received the SBOM now has one. So it's a very complex area, and you need to start with that SBOM, because if you don't know what the software units, the software packages are, you don't have anywhere to start. But that's just part of the solution. It's nowhere near a complete solution. So again, the key point we're trying to drive across here is the role of SBOMs in identifying software and enabling people to have a shared understanding of the software they use. This also comes clearly into focus with quality considerations that I mentioned earlier, but not going into that in great depth. But again, this is where the SBOM is critical. One concern, one challenge that people have is most current tools are proprietary. and they're becoming increasingly expensive because there's so much interest in SBOMs. There's lots of new startups getting into this area. The trend seems to be to charge based on the number of developers, so that can become very expensive very quickly. Not so good for the customer. The argument is that everyone benefits from, everyone in the development team will benefit from software composition analysis, but eventually that's probably going to become a problem for people to afford the cost of this. And it certainly hits hard at smaller companies that don't have the revenue to pay for these kinds of solutions. And particular proprietary doesn't work across the FOSS supply chain. So if you think about free and open source software, the majority of it starts what we call upstream. So it starts as a open source project. It may be supported by a foundation. It may be supported by some companies, but these are not revenue producing companies in any significant way. So if the tools are proprietary, it's possible the vendor will offer some free plan for you at some point in time with some particular set of features, usually a very restricted set of features. So if we're trying to fix this, vulnerabilities in particular as a supply chain issue, you need to be able to help the upstream teams, whether they're, again, whatever their configuration is, to start working on it in their own environment and not wait till the software's halfway downstream before anybody starts looking at the composition and the vulnerabilities and the licensing. So that's, again, where SBOMs come in, and SBOMs are a very, very hot topic within the software composition analysis tools. Mostly discussion, not a solved problem, but everybody is making some attempt to deal with the need to have an SBOM. In that context, I'm switching over here to a particular approach that nexB has taken. We believe in free and open source tools for open source, and we've started with modular tools. We've been building these tools for about a decade, but our idea is that anything the developer needs to work with should be free and open. Most of our software is under Apache 2.0, unless it's a in itself a third-party piece that we use, and then it's under whatever license it's under. And an area that's not receiving enough attention that needs to get more attention is you also need the data. I'll talk about that a bit more in the details, but it's not just about software, it's about data, and that's easiest to understand in terms of vulnerability data. So at this time, the main modules or products we have are ScanCode, which is a code scanning tool that looks at source and binary files and finds all the information about their origin, their actual identity, like the package URL, license information, vulnerability information, some other things that you'll eventually get from VulnerableCode. But it's mainly about identifying the software packages, software components, and their attributes, their metadata. VulnerableCode is a bit newer, but what we're doing here is there's both a set of tools and a database that we host online to aggregate vulnerability data. So there's data from large organizations like the National Vulnerability Database in the US, which is probably the grandfather here. But there's lots of other important information that can be coming from individual open source projects, from package repositories like an NPM or a Maven, from source code repositories like a GitHub or a GitLab. And they often have either different information about different vulnerabilities than the other sources, or different information about the same vulnerabilities. So we need to bring tools to bear to consolidate that information, get it all in one place. So you have package A, you can see what everybody is saying publicly about vulnerabilities for that package. Obviously, there's private information that we will not have access to, but we're plenty busy pulling together all the public information. The third sort of foundation here is something we call the Perl database, or the Perl DB. Perl stands for package URL, which is a mostly universal way to describe a package with a single string that looks like a URL. And as this is being adopted, you know the string, the name, if you will, of the package URL string is very helpful in identifying it. But it's much more helpful if you have metadata about that package, so that you don't have to go look it up yourself each time. But in fact, there's a central place to go to find out the details. So the Perl itself will typically tell you if it came from NPM or Maven or some other repository. But it doesn't, that name just allows you to go look it up. So what we're trying to do here is get that public metadata, aggregate it, compare it, organize it, and it includes tools for collecting the data and ultimately not yet published, but there will be a public database. When we talk here about free and open data, that is available, again, free and open, and nexB is hosting that data, but we are not able to just support every single use case. So if you have a high volume use case, we're a small company, an open source company, and there may be some money required to just support the physical infrastructure to distribute that data, or for you to have a private access to that data. There are many other projects I'll describe a little bit later. And then sort of as the SCA management layer, we have a product called DejaCode. This is currently a proprietary product. We're thinking about how to open source it. It brings together all these other pieces. Some organizations want to put their own management application together. Some people are looking for something that's packaged software. So there's no requirement to use DejaCode, to use any of our other tools. They're all quite independent. So this is kind of a picture of this. One thing that we do in DejaCode is we can both consume and create SBOMs. And DejaCode it's an application. It's got screens and reports and all the things one would expect from a business application. It's not a technical tool. So one of the key ones is policies for your licenses, policies for your components and packages, and then storing equivalent of a BOM. It's we can consume or import CycloneDX or SPDX SBOMs, and we can output CycloneDX or SPDX SBOMs. The internal structure is much more complicated, and of course, it has to be designed in a way that it can support either standard. So it's not literally an SBOM just being dropped into a blob somewhere. There's interpretation and so on. So DejaCode's kind of your dashboard where you can look at all the elements of your product. Also, typically in a development environment, you have 50% of the code that you have in any system or development system is probably internal use only. So it's not in the SBOM that you produce for your customer, but you still need to track that. We call that the inventory. So that's all in DejaCode. At the more technical level, ScanCode.io is a server that processes the scanning, and I'll discuss that in more detail. It can produce an SBOM, but it may be a case where you need to do a bit more review and analysis of the scan results before you turn that into an SBOM. Obvious cases are, if there's a choice of license for a component, you need some place to say, that was the choice, and I picked A, not B. That would be something to do in DejaCode. And we have other specialized tools. A container inspector is for analyzing a Docker container, a Windows container, a VM, something like that. It extracts all the layers of those images, inventories them, and detects all the packages, and various package inspectors. So for each of the major package repository, for better or worse, there are idiosyncrasies of each environment, and you need some specialized tools for that. And then underlying that, I've talked a little about the Perl DB and the Vulnerability DB. There's also a license database of about 2,000 licenses that we can detect in ScanCode, and that's a public database. So ScanCode works based on a set of rules and text samples from the actual license text. It's not a regex string processor. It's actually a matching technique, and there's very sophisticated processing for that. You can add your own licenses to the license database and rules for detecting them, or licenses from, say, a proprietary vendor that you want to put in there, but we wouldn't have because it's not public. So those three databases are underlying ScanCode.io and also underlying DejaCode. So starting from the top of the diagram, I mentioned already that DejaCode is an enterprise application. We sort of think of it as a system of record. Defining your policy is very important, but also applying your policy. So if you import an SBOM from a supplier, you want to have your policy stated so that you can immediately be alerted to any license policies that are potentially in conflict with what you're receiving, or a potential conflict in the incoming software with your policy. You want to be able to quickly scan for the latest package vulnerabilities. So when the supplier sent you the SBOM, they may have included information about vulnerabilities at the time they created the SBOM, but weeks or months later, that's going to look very different. So you want the real-time information for that. And then, of course, you need to generate the compliance documentations, attribution notices, and SBOMs downstream after you've completed your product and done, used whatever third-party pieces you are, but you're ultimately responsible for the product that you produce. It's all built in. When you install DejaCode, you have a copy of ScanCode.io, and you have access to the public instances of VulnerableCode.io and PearlDB, or possibly you could build your own. And it can be installed we offer a SaaS subscription, or you can install on premises. It really is not much difference except the installation process and, of course, where the control is. Switching to the open source side, ScanCode is, as I've said, I think it is the leading scanner out there, proprietary or open source. When you're in open source world, sometimes it's hard to find out who all is using your software because there's, of course, no requirement to pay for it or register. But we see the largest tech corporations in the world using it because they do contact us from time to time about it, and a good reason to believe it's being embedded in many, many places. At the simplest level, ScanCode detects the software units themselves, licenses, copyrights, and dependencies. Those are the big elements. There's lots of other data elements, but those are the big ones. And there's several different ways you can use ScanCode. So ScanCode.io is a server. It has pipelines, so you can define a series of steps which you want to perform against a code base, against a package, against a container, any type of software you want. And then it has a UI for displaying the results. ScanCode Toolkit is the engine that does all the scanning. It's built into ScanCode.io, but you can also use it as a command line tool or as a library on its own. Lots of people do that. I mentioned LicenseDB. That's the set of about 2,000, or slightly under 2,000 licenses that we can currently detect. It grows by a few dozen every month or so. Again, it's all based on rules. The rules are in plain text. They're quite easy to see. As you can imagine, when you get to this volume of licenses, I mean, it is complex, but we kept it as simple as possible. And if you want to add a license, you add data to the license index. You don't have to write code. Some more specialized tools. One, ScanCode Workbench, which is a desktop app. If you're using the ScanCode Toolkit, it makes it easier to visualize what are some very large files sometimes. And in sort of a metadata world ourselves, we have ScanCode Analyzer, which is a set of specialized tools to improve license detection accuracy. So we're constantly working with people across the open source community and major companies to improve the detection. Licensing is a very creative endeavor, and people are constantly changing words, changing the structure, changing the terms, and you have to keep up with that. Our focus is on the licenses that are actually out there that are being used in software. That's one of our prime criteria is, what project is using it? What evidence do we have that it's actually being used? There are quite a few people who create what we call vanity licenses. So those are making a statement of some kind, often of an ethical nature, but not necessarily used in any software or used quite sparingly. VulnerableCode, it pulls data So this is when we're talking about vulnerabilities, all the public sources, individual projects, GitHub, GitLab, Linux distros, the National Vulnerability Database, package managers, others. We really do look upstream to projects, but you can imagine that's a pretty huge domain. Not everything is on GitHub or one of these public larger repositories. But another important part of this is understanding getting information from different sources, being able to evaluate how accurate and useful the information is from each source, and what's the overall quality. So as we get deeper into this, we find often, fairly often, more than you'd like to see, cases where a vulnerability is reported for a version of a package that never existed. And also, vulnerabilities that don't really quite make sense. So what we're trying to do is collect this information, not just collect it, but understand the relationship between them, the inconsistencies, and essentially confidence factor for the quality of the data, as well as the very severity scores that come in for the possible impact. There is a public version of this database, which you can use. You can go look up an individual package, or you can use the API. You could also build your own if you're in the mood for that. And our next steps here are working on more sophisticated data sharing and what's called curation, ways that anyone in the community can come in and help us improve this data, either digging into what the vulnerability is and what its impact is, or looking at how ways to mitigate the impact of that vulnerability. Our newest project, from the point of view of being available, though we worked on this for 3 or 4 years, is called PearlDB. So I mentioned earlier, nexB was involved in, or responsible for, starting the Perl specification package URL. And what we're focusing on now is building a database of package metadata from public sources. So very similar sources in some ways to VulnerableCode. But here, what we're looking at are all the available metadata about the package. So it could include license, include all kinds of URLs, where can you download it, where can you report a bug, who are the authors, all sorts of things. So that's one. Just having that data, which we've collected for some time but be making public, is useful. So you don't have to go look it up and go 6 different places for 6 different packages. They may be, there's logic that they may be in different package manager repositories, but from the point of view of your project, you want to be able to see them in one place. And a very big important thing called package matching, which is a complement to scanning. So if you have, for instance, binary files that have been stripped of all symbols and got or obfuscated in some way, the only way you'd be able to identify that package may be by matching it to a copy of that same package that appeared elsewhere. So an example would be if people use user space programs for Linux, all sorts of things in there. Those are often supplied in a binary form. They often represent a subset of a project, so some libraries, not the whole project. And you need to be able to identify them by the name of the binary package, not by the name of the source. So that's something that will come out of a package matching database. The best example of that may be Maven. And as with VulnerableCode, there are tools to build your own database, but we think most people want to use one that's pre-built because it's not everybody. It's our specialty. It's our full-time job, not necessarily anyone else's full-time job. So you can see what we have today at the PearlDB on GitHub, and also from other projects. Just to let you know the scope of this. Container Inspector is a specific tool for Docker, other images. Debian Inspectors for Debian packages. NuGet Inspector for NuGet, C#, Python for Python. You can see sort of the pattern here. Particularly the ones with the dependencies. Each package manager has a very specific scheme, and it takes quite a bit of expertise and knowledge about that environment to resolve the dependencies. Here, we don't reinvent the wheel. We use what the package manager provides, and then enhance it and standardize it so you can get a consistent view across all kinds of packages. We have a tool called AboutCode Toolkit, which you can use to generate attribution notices. It's pretty specialized, but pretty important part of your compliance obligations. And then I mentioned the package URL. This is a shared project with other organizations, but really important to understand that specification. And one of the reasons Perl has moved so quickly into a de facto standard is because the various communities, particularly package manager communities, adopted it and started providing the software to implement it. So it comes back to the point that you can't wait for the standards to be finalized. You need to engage early and evolve as they evolve. All of our projects are available on GitHub under the nexB heading. So every single one, there's close to 30 total at the moment. And sort of a closing item of why are we talking about this? Why would you be considering working with nexB? Well, we are experts in this area. We've developed best-in-class tools, and our mission is to provide FOSS for FOSS. So provide open source tools for open source and support the ecosystem. We are a company. We have to find ways to support that and need help from companies that are in the same wavelength as us, and many of them sponsor our projects. We also do things like software audits with our expertise. We've done hundreds of projects, particularly for acquisitions. So there's lots of different areas we bring the expertise to bear. But again, our mission is to get these tools out there so the open source ecosystem can flourish. So we've been, on the forefront of package URLs, I've mentioned a number of times, and Philippe and I were co-founders of SPDX itself and co-founders of the Clearly Defined effort. So we've been involved for over a decade in this work and building our tools based on the open source mission. So you can contact me. I'm the CEO of nexB, Philippe's the CTO, and Dennis is the DejaCode product manager. Any of us could help you out. You can go to nexb.com, contact us there, or you can get to us on GitHub or other sites. But anyway, this is a quick way to get a hold of us. We're a small, fully remote team, so email's the best way to reach us. And thank you for attendance today. Be happy to get any of your questions, and we'll be following on other topics in this series soon.